we pick this up now. We're going to finish up in this cable problem, and we're using this as a conduit for teaching you that array. Those of you who have really taken to using spreadsheets in estimating class and any number of things, you have to realize that spreadsheets are nothing more than tables or matrices or arrays. Those three words get mixed together a lot. So basically a lot of these things are you've been doing, but you do want to get exposed now to some kind of hidden gem, if you would, of Excel as well as your calculator in terms of learning to use and manipulate matrices. And so if you think about a matrice being a list and any point being a list of 3 coordinates, or maybe 4 if you've got time, this is how you go about making a matrix or a range and using matrix operations in Excel. And it's that you actually have to hold the shift, the control, and the return when you do your operations. So we're going to start this way by first defining our 4 points just in a normal way. We've got point 1, 2, 3, and 4, and you see the first one was 25 in the X and 25 in the Y and 0.8 in the Z. This is corresponding to the video that was prior to this, 25 in the X and 0 in the Y and 8 in the Z. And of course then finally 0 in the X, 25 in the Y, and 8 in the Z. And then I arbitrarily came up with this 16.67. We'll see later as you start adjusting cable length, 16.67 and 4. We'll be doing this inside of our Revit structures. And if you think about one of the better analogies to this, it could be just literally a 3D camera that's hung on some cables that you see nowadays in sports. So we have this, and you see each of these, looking at them, you can know that they're X, Y, and Z, or you can define it. We can kind of do this if you want. Just right click, insert. We can say that is your X, and this is your Y, and this is your Z. And of course, in the end, that if you're going to go about, in all reality, you could go about doing this. All right, I'm going to pull out my little review here, and right on top of this, I could go to my review, I presume, and start inking. I could go to the fact that this is the same as 25I plus 25J plus 8K, which usually will be written up as 25, 25, 8 as a list, or in AutoCAD you would see it 25, 25, 8. So the fact that these are all the same thing, but in this program, in Excel, by going and doing this, highlighting, and I'm going to stop my inking now, I'm going to close my ink tools. By doing this in Excel, you actually define it as a range. And so what you do is you're going to first come across here, you're going to highlight across here, you're going to right click and name the range, and you see what it's going to name it to. We're going to go at PT1, and I'm going to put an underscore there because that's what it did last time. So PT1, that's that range. We have to enter a unique name, and that's because I already named it. I'm just going to go PT1A underscore because I have actually quit out and done something prior in this spreadsheet. PT1A, I'm going to go here, go across, I'm highlighting across, right click, naming a range, PT2A, I'm putting the underscore there. I don't know that that's necessary. And then finally, across the top here, right click, name a range, PT3A underscore. And then finally, this is what? Right click, name a range, PT4A underscore. Now, what I've done now is I've made actually lists or matrices of that. So now if I think about cable A here, the way I go about doing all the operations at once, and we're going to do this because we're going to be thinking about kind of taking matrices and putting them together and multiplying and doing transpositions and reverse row echelon, is this. I can go, what I need to do is I need to highlight all 3 of the cells that I need to carry my full matrix or list, and then as I go here, as I've got them all highlighted, I then key in my formula. And so my formula here will be E, and I could actually use the name point at point 1a and point 2a, but I'm just going to do this right now. I'm going to go across here. I'm going to say we want that minus this, and now I hold the shift, the control, and the return key, and I actually stick the matrix there. Now if you think about this formula here, I'm going to go to the next two, this time using that Alt F4 that you all, or F4 that you all showed me a second ago. So I'm going to go to here, and I'm going to once again highlight all three. While those are highlighted, I'm going to say equal. I'm going to take this 0.2 minus 0.4, and I'll just see what happens when I hit F4 here. Ah, beautiful. Isn't that wonderful? We all can learn. Then I need to hold Shift, Control, Return, and you see it puts the second matrix there. And now if I do this point here, right-click, copy, and then go to here, all the way, click right-click, paste, I'm going to have my final matrix. Now, the weight, of course, we know is going to be 0, 0. In this case, I'm going to give it a number because this formula is not, and it's a minus W, right? So this basically, minus 10, I guess, is what I'll use because I can't use W. Now, you'll see now here we have this vector. These are the describing the vector. Now, if we want to divide that vector by something, we can take, and I'll just place that over to here. We want to get the unit vector, and the unit vector is going to be equal to, and I'm just going to more or less put the magnitude of the vector here first, equal to the square root of, let's see if this works, all the way across squared. Square root, I'm going to say that squared. That doesn't work for me. I'll just say equal to square root of the sum of the all the way across here, squared, close parentheses, and then I'm going to try to do a Shift, Control, Return, and you see it gave it to me. Now, I don't think it's necessarily right, but it does kind of do something with matrix here. So I'm going to hit a pause here, and then we're just going to do a regular calculation and do the rest of the matrix here pretty quick. All right, I'm just going to use, what we're going to do is we're going to try to calculate this normalized vector, which of course is each of these divided by the square of the sum. So let's just get that as a standard formula here. Equals square root of this squared plus this squared plus this squared. That's going to get me, of course, I'm going to hit a return here and see what it gets me. It doesn't get me anything. We'll try that again. The square root of B8 squared plus C8 squared plus D8 squared. Got a problem there with my plus. So once again, you're all used to that. We now have that value. We can go right-click, copy, go across here, right-click, paste. And now we have these three lengths of the vectors, three lengths there. And now we can kind of come up with our unit vector in each of these by doing this. We can, I believe, at this point, take this and say equals this divided by this, and then hit Shift, Control, Return, and you get the unit vector. Do the same thing here. We can now take a copy, right-click, paste, right-click, paste, and you have in this the vector, unit vector for cable A, cable B, cable C. But the next thing you're going to see we're going to need to do is we're going to need to transpose it, which is more or less flip it. And I'll show you that right after we pause. All right, we now have these are each individual lists, but we can go ahead and do this. We can go ahead and take these three things now, right-click if we want, name a range, and this would be our maybe description matrix. Once again, it's not very important for us to name these things, but it's not a bad idea later when you're talking about individual vectors. So now we're going to transpose it. Here's how we transpose. We have to, again, grab the full set of cells that we need, then go to the beginning. You have to do the full. You type in E transpose, open parentheses, go all the way across what you want to transpose, close your parentheses, and now you have to hold Shift Control Return, and you get the transpose matrix. We'll pick it up from there, but give that a little try. You've been using matrices a long time and Excel a long time. If you can master this, you've opened up a very large world of computation.